Good evening, everyone.
I hope my voice is clearly audible to all of you. If you can hear me, if everything is working fine, I'll quickly want you to give me a quick thumbs up or a yes in the chat so that I'll know that you're able to hear me, and we can get going with this very particular session on average mixtures and alligations. So uh, quickly, anybody who can hear me, just quickly give me a thumbs up, and we'll straight away get going. Right, I can see around 6 odd people, 7 odd people at least, if not more, watching live. If you can hear me, if you can see me, quickly give me a thumbs up. Yes, anything would do, and we can get going. Alright, voice is getting echo, that's a feedback that I've got. I'll check if I can manage that, if there is. Alright, I'll check if I can do something about it. Alright, voice is not clear. Is it not manageable at all? I mean, if there is a lot of disturbance, I'll maybe take a minute to adjust it. Otherwise, if it is just a minor echo, we can probably get going with the same. Alright, I hope it should be better. Alright, just give me a minute, hopefully everything should be fine. Alright, I guess there's not much that we can do about the voice and the echo. Hopefully this should be better with some of the changes that I've made. Without wasting any more time, let's get going with our session on average mixtures and alligation. Now, in this particular session, understand that we're going to discuss some CAT PYQs as the title says, but let me give you a broad agenda as to what is it that we are going to broadly cover, so that for the next 45 minutes to 1 hour that we are together, you have a fair idea as to what is going to happen. So typically we'll start with a very interesting concept in mixtures, which is that of transferring from one glass or container to another glass. So you might have seen such type of questions a lot, where there is some quantity of alcohol or water or milk or water being given in particular containers, and then there is a transfer that happens from one container to another container. I've seen that a lot of students face difficulty in trying to understand what typically happens when you transfer from one to another, how to go about it, and a lot of times just on the basis of looking at some of those questions, students tend to skip those questions. So the whole idea behind this session is to pick up certain standard variety of questions that have frequently appeared in CAT. So the discussion that we are going to have is purely based on past research for all the papers that have that are available for us from 2017 till 2025, with the most recent CAT 2025 being focused. So we'll try and understand what type of questions typically come, understand the basic concept or approach to deal with those questions, and then take it up from there in terms of practice and application on how do you go about solving those questions. Yes, I can understand that the voice is having a lot of ego. I've tried a few things at my end. Let me know if this is much better. I think there should not be any echo. Quickly confirm if this is fine. It's about 10 odd minutes that we have already spent, not a big issue. Alright, I'm assuming that things would be better for now. If they are, yes, problem gone. Thanks a lot. All good? Perfect. So what is a YouTube live session without some amount of glitches? So I think these are things that are beyond our control. So everything is in good condition hopefully now. Let's get going with our sessions. As I said, there are certain standard concepts that we need to understand before we jump to questions so that we can create an approach where we can get going with solutions for some of these questions. So first I'll start with basic theory to understand how to approach certain concepts or question types that come. So let's begin with that particular concept with regards to understanding how to approach particular theories. So if you look at certain category of questions with regards to mixtures being transferred, typically the condition that we get, as you can see on the slide, would be that there would be, let's say, a container A which would have only pure milk. And just for the sake of understanding, as you can see in the slide, I have taken milk to be 300 liters, water to be 0. So total quantity is 300 liters, right? Yes, I'll take your questions. I'll answer all those questions that I'm seeing in chat later on. So if you feel that there are certain questions you have at the end, we can definitely discuss them. So let's focus on mixtures. So a pure milk container of A with 300 liters of milk, water being 0, and you typically have another container B which has pure water. So there is no milk, water 300, total being 300. Standard thing. I'm pretty sure you have seen such scenarios while you have studied at a basic level or practice questions previously. Now what typically happens, or question typically says that some amount of quantity from container A is transferred to container B. So let's do that. Let's take, for easy calculation purpose, 100 liters being transferred. So if we transfer 100 liters from A to B, then what will typically happen? You will have milk getting reduced by 100. So in container A, you will have milk as 200. Total quantity will become 200. This 100 gets transferred to the container B, which has now milk has 100, water being 300, and total quantity being 400 liters. So I think this much is pretty straightforward because container A contained only pure milk. But now the story changes. Suppose now we take out 100 liters from container B. Suppose now we take out 100 liters from container B and go back to A. So then would only milk be taken out? Or would only water be taken out? Or would a mixture of both milk and water be taken out? So I'm pretty sure it's pretty easy to understand that because now there is a mixture in B of milk and water, and we'll assume that it has dissolved or stirred really well, we'll have a mixture. And in what ratio will that mixture come out? That mixture will come out in the exact same ratio as it is already present in the container B. So currently milk and water, if you can see, currently milk and water are in the ratio of 1:3. So when you take any quantity out, milk and water will also come out in this very same ratio of 1:3. So suppose we now take out 100 liters from B and transfer it to A. Can I say from those 100 liters, 25 liters of milk will be taken out and 75 liters of water will be taken out? So how will the situation in B look like? B will have 75 liters of milk and 225 liters of water, total being 300. Now before we move on to the position of A, very quickly observe that even after you have taken out this much, the final values are still in the ratio 1:3 only. So 75 and 225, because it was already present, you have taken out something else. So whatever is left also remains in the same proportion, it doesn't change. So milk water was earlier 1:3, it still remains 1:3 in B. Now what will happen in A? So this 25 gets added to the milk part of A, this 75 gets added to the water part of A, and finally 200 plus 25, we get 225 of milk and 75 liters of water. So basic process of transferring from A to B, 100 liters, and then transferring 100 liters back to A. This entire process in typical questions is called as first iteration. Now you might have a second iteration, third iteration, and so on. Generally 3 iterations are the maximum that I've seen ever in any of the questions historically that have appeared in any of the exams like CAT, XAT, etc. etc. So typically this process is now clear. Now there are some interesting conclusions or takeaways that we can draw. Once this process is done, now I want you to observe milk in A and water in B. I hope you are able to see this. Milk in A is 225 liters, water in B is 225 liters, both are same. Now, is this because of the values that I have taken as 300, 100 and therefore they are coming out to be same? Or if we do the same process with the constraints being that you take out the same quantity from A, transfer it to B, take out same quantity from B, transfer it to A, you will always have the milk in A to be equal to water in B. This will always be the same. Same is the case with if you observe the quantities of water. So water in A is equal to the milk in B. Now these are some very important takeaways. As a result of this, you can also say that the ratio of milk to water in A is equal to ratio of water to milk in B. So when you look at the container A, milk was more, so ratio of milk and water will be same. In container B earlier water was pure, so it will be equal to the ratio of water to milk, reciprocal. Milk to water in A, same as water to milk in B. So these are the important takeaways that we can have from this particular discussion. And you'll be surprised to see, sir, this was very simple. This is something that was kind of known to us earlier. Not very difficult, not very challenging. You will find that there are some very interesting applications from CAT questions. In fact, CAT 2025 itself had a few questions based on this, which you will find to be very easy to deal with if you have understood this. So to quickly summarize, the key takeaways were milk in A is equal to water in B for this particular setup. Water in A is equal to milk in B. This will always be true as long as 100, the same quantity is taken out every time and the iterations are complete. There has been a tricky question as well where different quantities of water have been taken out. We'll take care of that later. And finally, ratio of milk to water in A will be equal to ratio of water to milk in B. If you have understood this or this much so far, then it's a good time for us to quickly jump to a question from CAT 2025 slot 3. I'll give you 10 seconds, those who are watching live, around 15 of them as of now, quickly go through this question, try and figure out what is happening, and then we'll look at the solution on the basis of what we have understood so far. Right? Alright, so I'm assuming that you have read the question. Vessels A and B contain 60 liters of alcohol and 6 liters of water respectively. So something similar to what we have studied so far. A certain volume is taken out from A and poured into B. After stirring, some volume, no, not some volume, same volume is taken out, which is actually the key to the concept that we've studied so far. Same volume is taken out from B and poured into A. If the resultant ratio of alcohol to water in A, remember what we studied? Alcohol to water in A will be equal to water to alcohol in B, perfect. Then the volume initially taken out. So let's quickly build the scenario. A contains pure alcohol, B contains pure water. This much is pretty straightforward. Now once you take out X liters, and that is the quantity that we are asked, finally what is the question asking? The question is saying volume in liters initially taken out from A. What was the volume taken out from A? So the volume taken out, let's assume it to be X. So what will be the situation in case of the vessel A? You will have entire alcohol of X liters being removed. So alcohol will become 60 minus X. Water was initially 0, so it remains as 0 and total becomes 60 minus X. What will happen in vessel B? Now this entire X liters of pure alcohol is getting transferred to B. So we'll have alcohol as X. What will happen to the water content? Water content remains the same because there is no water getting added, and the total will increase by X. So total will become 60 plus X. This is the current situation. Now we need to take out the same amount, which means we need to take out X back again to A. So we need to take out X back again to A. Once we take out X back again to A, I'll just quickly erase the part that is already there, overlapping. So once this happens, what will happen? A lot of people waste a lot of time saying, okay, now when we take out X, this will be in the ratio of X is to 60. So we'll have x upon the total quantity is x plus 60 into x. This is the amount that will be taken away, and from here you will have 60 into x upon x plus 60. This will be taken away, 60 into x into 60 upon x plus 60, and then you subtract, put it in the side of a, and then solve. There is absolutely no need for you to do any of this. Once you have reached this stage, just look at the concept that we have arrived at, where we said that ratio of alcohol to water in A is 15:4. So after the process gets completed, after x liters are put from B to A, alcohol to water is 15:4. So can I say water to alcohol in B will also be 15:4? If this is the case, 15 corresponds to a value of 60. This ratio 15:4, 15 corresponds to a value of 60. So the multiplication factor is what? The multiplication factor is 4. So we'll multiply 4 here, and 4 into 4 is what? 16. So we get the value of x to be as 16 liters. That's our answer. So a lot of you might not have been able to understand it straight away. What happened after 415 and why did you do it directly in B? But this is the beauty of the concept that we had studied earlier. So let's revisit quickly and then let me know if you have any doubts or questions. You can also ask the questions in the comments later on if you are watching this video later on. Also share your feedback in the comment section with regards to what parts you felt you could apply in a lot of other questions. So let's revisit. What was given to us after the iteration was that the ratio of alcohol to water was 15:4, correct? So the ratio of water to alcohol after the iteration will be 15:4. Water will be 15, alcohol will be 4. Now even if you take out certain quantity of x, the ratio 415 will remain the same, because as we have seen in the earlier experiment, if there is a certain mixture, you take out anything from it, whatever was the ratio earlier will remain the same, because you are not changing the configuration or the ratios of alcohol and water. So this is also the ratio 15:4 just before we take out x liters. And now because this ratio is 4:15, currently they are present in the ratio of x is to 60. So essentially we are saying 4 upon x must be effectively equal to 15 upon 60. And that is what we are doing. We are cancelling this by 4. We get, after cross multiplication, 4 into 4 as 16 liters. So this becomes our answer. If this question is clear to you, if yes, there is a practice question coming your way. I want you to spend 30 seconds, and I am assuming that you should get your answer in 30 seconds, and share your answer in the chat if you are able to solve it. If you are not, maybe you can try it later, but for the next 30 seconds quickly try whether you are able to solve this question. Yes, any answers so far? All right. $15. Perfect. Excellent. 15 is the correct answer. Supernova. Fantastic. So I'm leaving this question for you to solve. If you get the answer, please share it in the comments, and also the time in seconds approximately. Maybe you do 1 minute, 1.5 minutes, whichever method. And if you feel that you want to get the answer within 30 seconds, maybe watch the rest of the video if you have not watched it live. So I'm moving ahead now. So I'm assuming that you should be able to solve this quickly. Kundan, fantastic. I have Anish as well. Anish would be fantastic. 3 people giving correct answers. 15 should be the correct answer. Excellent, fantastic. Let's move ahead to the next question, right? Now, We have already seen one question from CAT 25 slot 3. This is a question from CAT 22 slot 3. I want you to just read the question and then try and answer it on your own on the basis of whatever we have studied so far. So we are not discussing anything which is out of the ordinary or something which is created just for the sake of creating that wow factor. This is an actual CAT 2022 slot 3 question. Just quickly observe and tell me the answer. Choice 1, 2, 3, 4. What should possibly be the answer? Glass contains 500 cc of milk, cup contains 500 cc of water. From this glass, certain amount of milk is transferred to cup. Learning co-pilot, fantastic. Choice 3 you are suggesting. And you might say, sir, there is nothing to solve here. This is exactly what we studied in the theory part. And understand, a lot of times as students we feel, sir, this might have been engineered because this was a question that came in CAT. No, this theory that we studied in the first maybe 10 minutes, 5 minutes of our session is there since time immemorial, if I can use that phrase of language. So during the times that I used to prepare for CAT, the same basic standard theory of mixtures transferring from A to B, then back again from B to A is going on. So this is not new. This is a question, you can say, fact based in CAT 22 slot 3. A lot of people, if you know it, you know it. The answer will be option 3. Correct, Kundan? I am skipping the solution for this question as well. Exactly same as the theory that we started at the start of the class. You can go back and watch that part again. Share it in comments if you are surprised that this is an actual CAT question which might take 5-10 seconds just because you know it as a fact. But that's true. And this is where we categorize a lot of these question types as type A. So this is definitely one of those type A question types, depending on whether you are thoroughly prepared. Alright, let's look at the next question type then. Correct answer for this obviously is choice 3, 1:1. Amount of water in glass will be same as amount of milk. Nothing to discuss. Let's move on to the next question. Now this is slightly different. So again CAT 22 slot 2. 2 containers, same volume containers. First container half filled with sugar syrup. I'll again want you to take 30 seconds, quickly read, go through this, and then we'll see how to approach this particular question type. Alright, now having read the question, there are 2 containers, this much we know. One has sugar syrup, the other has milk. They are half filled, so capacity is more, the quantity is half filled. Half the content, so the key message that we get here is half the content of the first container is transferred to the second, and then half of this mixture. Now one very important piece of caution here, once you transfer half from first container to second, and then you transfer half of the contents from second to first again, you are not transferring the same quantity, which means the assumption with which we have built our entire premise so far in the basic theory does not remain valid. Now this process of doing half of this mixture is again transferred, next half of the content of first container is again transferred. This is overall happening thrice, A to B, B to A, and then again A to B. So you are expected to do half thrice. Now anybody who has studied for any competitive exam, if you have even started, this is a no-brainer that if you have to do half 3 times, it's always a good idea to start with values which are multiple of 8 or 16 or higher powers of 2. Why? Because if you are going to halve few things 3 times, so half into half into half, you will effectively be doing 1/8. If values are multiple of 8, it becomes much easier for you to do those calculations. So that is the first takeaway when you solve this question. Now let's create the scenario for the two containers. So you have container 1. Container 1 contains sugar syrup and there is no milk in container 1. Let's create container 2 as well. Container 2 has sugar and milk. Now they are saying half filled with sugar syrup. Now this half filled quantity I am assuming it to be 80 for sugar syrup in container 1 and 80 to be milk for container 2. So effectively we can say that the capacities of containers are 160, doesn't matter. Now what is happening? Now they are saying effectively milk is 0. Here sugar syrup is 0. Half the content of the first container is transferred. Now this should be very easy. So 80, if you halve it, it will become 40. So what will be the situation in container 1? 40 and 0. This 40 sugar syrup directly goes to container 2. Milk remains the same. So we have 40 and 80 as a configuration here. Now they are saying half of this mixture. This is where the things become different. Half of this mixture. So earlier we did half of this. Now half of 40 and 80. So what will remain? 20 and 40 will remain here. And this 20 will go to sugar syrup in container A. So this will become 60. And this 40 will go to milk. So milk will become 40. So we'll have 60 and 40 as sugar syrup and milk. So this is the second step done. Now they are saying next half of the content of the first container is transferred back to the second container again. So now we are again going to transfer half of the contents. So what will remain here? Half of 60, 30, half of 40, 20. So this 30 and 20 gets added here. So 30 plus 20, sugar syrup becomes 50 and 20 plus 40, this becomes 60. That's all. That's all you are required to do. Now they are finally saying the ratio of sugar syrup to milk in the second container. Ratio of sugar syrup to milk is nothing but 5:6. Choice 1 becomes answer. So now this is a different question. This is slightly different from what you've studied so far in terms of the basic theory, but not all question types will have the same set of assumptions and constraints that we've seen, but doable. Why? Because we have seen what happens when you take out contents from one container to another container and so on and so forth. So I hope this should be clear. Can we move on to the next question? Shall we? If yes, let's look at this question. So again, maybe 30 seconds for you to solve it completely. Maybe 1 minute, maybe 1.5 minutes, but definitely doable under 2 minutes. So quickly read it, go through it, let me know how do you find this question. CAT 22 slot 1. Alright, let's look at how to approach this. So mixture contains lemon juice and sugar syrup in equal proportion. So there is a mixture where lemon juice and sugar syrup are equal. So let's write it down just for the sake of clarity. Lemon juice and sugar syrup in equal proportion. So I can say the ratio is 1:1. So the total quantity of mixture is, let's say, 2 units. Now if a new mixture is created, how are we creating this new mixture? By adding this mixture. So the mixture that we have here, we are adding this mixture with sugar syrup. So we are just taking sugar syrup and this mixture in the ratio 1:3. Now understand that the total quantity we have already taken, just because we have taken 1 units, total quantity of this mixture we have already taken as 2 units. If we are to mix them in the ratio 1:3, can I say sugar syrup has to be 6 units? So then I take 6 units of sugar syrup and mix both of them together. So we'll have 2 and 6, total 8 liters of mixture being formed. What will be the quantity of lemon juice in it? Lemon juice will be 1 unit because lemon juice was there only in the mixture. What will be the quantity of sugar syrup? Sugar syrup was 1 unit here and 6 units here. Sugar syrup was 1 plus 6, 7 units. and that is what they are asking. The ratio of lemon juice and sugar syrup is 1:7. Correct answer, choice 4. Now, although this is a relatively easier question, you can write it down and solve. I want you to spend the next few seconds trying to visualize this in your head. And this is something that I would encourage that you do a lot even after you have seen a solution. That I am going to erase everything that I have explained. Yes, correct answer is D. 1:7 supernova. I can understand that after explanation the question seemed easy. Yes. So I'll erase this. What I want is, I want you to quickly pause and just visualize this in your head, that you have mixture, you have sugar syrup, mixture 1 unit, sugar syrup 3 units. What is in this mixture of 1 unit? 2 halves, 0.5 lemon, 0.5 sugar syrup. So you're just mixing them up, adding. So 3 units of sugar syrup, and already in this mixture you had 0.5 of sugar syrup. So total sugar syrup was 3.5 and lemon was 0.5. That is what they are asking. They are telling you the story and they are asking you, okay, did you hear what I say? What did I say? So it's like lemon 0.5 and the entire sugar syrup being 3.5. They are asking this is the ratio. 0.5 is to 3.5. You cancel the decimal, 535 ratio 1:7. You do this in your head on your own. Try and see whether you will be able to understand the 0.5 breakup for 1 unit of mixture, and then we can, this is something that you can do regularly even if you have solved certain questions to get better understanding of that. So this was pretty easy, I hope. Let's look at one more question. So this is from CAT 25 slot 2, and believe me, in the exam pressure, this looks time consuming. A lot of people, a lot of students felt that this is type B. Mixture of coffee and cocoa, 16% coffee, cost is 240. Another mixture of coffee and cocoa, 36% is coffee, cost is given. The moment you read this much and then they are asking in a new mixture of 10 kg, what will be the quantity of coffee, something like this. In the exam pressure, this looks time consuming, not really A type. Most people will mark this as type B, which is okay. But now that we are preparing, you don't know in the exam scenario what questions you'll be able to have, that eureka moment where you'll feel, okay, this is a question that I'll be able to solve very, very quickly. So maybe this could be that question type. At least while analyzing and while looking at solutions, we should be able to find alternate approaches. What would be the fundamental way to solve such questions? Fundamental way will be that 16% of something is coffee. So 84% will be cocoa or cocoa, and let's assume that coffee to be A and cocoa to be B in terms of price per kg. So 16% would be 0.16 A plus 84% of B, so this will be 0.84 B, and this effectively is 240. So you create an equation like this. Then there is another mixture of the same contents, of which 36% is coffee. So you have 0.36 A plus remaining 64 will be B, to 0.64 B, and the cost is 320. Now we have two equations, two variables, but the values are not very convenient. Even if you cancel by 4, multiply by 100, this will become time consuming for you to calculate the values of A and B, which will give you what? The price per kg of coffee and cocoa. Now they are saying if a new mixture of coffee and cocoa costs 376, so now a new mixture would come, you will have certain percentage, let's say K percent or P percent, so P into A plus you will have 1 minus P into B, and then this entire value will be equal to 376. You would have already found the values of A and B by using the two given equations, and then you will put this in equation 3 and get the corresponding value for P. If you go by this approach, definitely it is time consuming for anybody, irrespective of the person solving. If somebody solves via this method, this is time consuming. There will be a difference of 5, 10, 20 seconds depending on calculation, but definitely will take more than 2.5, 3 minutes, maybe 3.5 minutes as well. So I'm not going to follow this approach. Can we use a basic concept of proportionality? Yes. Can we use a basic concept of proportionality? Think of it this way, that 16% coffee actually results in 240 being the cost. If there is 16% coffee. If there is 36% coffee, then the overall cost is 320 per kg. So can I say because of a difference of 20%, there is a price difference of 80 rupees per kg? 20% is resulting in price difference of 80 per kg. So can I say 1% is resulting in 4 rupees per kg price difference? Simple ratio. So now in the next scenario they are saying the mixture is now costing 376. So what is the additional extra rupees per kg that we are getting? 56. How do I get it? 376 minus 320. So for 4 rupees per kg increase, we had a net percentage point change of 1%. So can I say for 56 rupees per kg change, we'll have a multiplication factor of 14. So can I say I just need to increase 14 percentage points here. So 36 plus 14 will have 50% coffee. So that is what they are asking. 50% coffee will now cost 376, that was given. They are saying then the quantity in kg of coffee in 10 kg of this new mixture. So if the mixture is 10 kg and you have 50% coffee, what will be the quantity of coffee? 5 kg. You will input your answer as 5. This was a PYQ question and done within maybe 1.5 minutes. With explanation, if you are able to have this in your own head while solving, I'm pretty sure that this will take less than 1 minute. And one interesting thing that you can do is just change the values a bit. And in today's age, I don't need to tell you how can you get new questions created. So just change the values, understand this particular question type, and then practice 2 or 3 questions of similar type. So you will get a good idea in your head, so that even in the exam pressure, you are able to have that understanding that this is one concept that I can apply when such a question comes. Yes, 5 is the correct answer. I hope this part is clear. You can move ahead to the next question type. Again, CAT 25 slot 1 question. Whole lot story. 200 liters of solution containing acid and water having 30% acid by volume and so on. Now again, I use a basic concept, one fundamental understanding, and then you should be able to solve this question with a lot of ease. So 10 seconds, quickly go through and then we'll solve it together. By the way, how do you categorize this? Type A, Type B, Type C? You can also share that in chat. Alright, let's now approach this question. So for a lot of people, this would be categorized as either type B or type C for sure. And I can understand, and I in a way agree as well, that on the face of it, this doesn't look to be a type A that we can just move ahead and straight away solve it in a minute, minute and a half, 2 minutes. But nothing too complicated in terms of fundamental understanding. If you are preparing for CAT, if you have attended classes, if you have studied, so to say, this topic, then what is it that you will say? If a junior asks you, sir, you studied for your prepared for CAT, what comes on average mixture alligation? So this is one of those 4 questions that you will say, there will be some mixture of acid water, some percentage will be taken out, replaced with water, replaced with acid, something of this sort. This is exactly what they are giving. So on clue, on dot, perfectly aligned with syllabus. So then this should be our strength. If something out of the ordinary comes, then we can always say that this was not expected, something very different. But this, I think, should be something that we should be very well prepared with. So the first thing, 200 liters should be irrelevant here. Why? Because everything else is in percentage. And finally, they are asking percentage of acid by volume in the final solution obtained. So we are dealing with percentage in the final answer. Everything else in terms of data is in percentage. The only data is 200 liters of the solution. So I don't really care if it is 200, 2000, 100, 1 liter. Doesn't matter. I deal with percentage. It has 30% acid by volume. Now, the way I structure this is that initially acid is 30%. So water will obviously be 70% because the solution is of acid and water. So 30% acid is given, water is 70%. Now Atul replaces 20% of the solution with water. Now standard concept, whatever is the percentage of acid, irrespective of whether you studied it via formula, via transferring, to taking out certain values, think of it as a revision of the concept that you studied, or learning it as a new concept that whenever you are replacing 20% with water, when you are already given some proportion of acid or water, alcohol water, milk water, etc., understand that what will happen to acid is, because you are replacing with 20% water, effectively acid concentration will become 80%. So take the 100th complement. If you are replacing it with water and 20% is getting replaced with water, what will be the impact on acid? Acid will effectively become 80% of itself. It will go down because we are taking out acid instead of water, putting pure water. So water percentage will increase, acid percentage will go down. What will be the value by which it will go down? So it will become 80% of itself. So what will be 80% of 30? So I can say 24%. So 24% acid and water will be remaining 76%. Once you have understood this concept, that once you replace 20% with water, acid concentration, alcohol concentration, milk concentration will become 80%. So then life should be easy. Now the question from CAT 25 gives you a twist. Now it says it replaces 10% of the resulting solution with acid. 10% of the resulting solution with acid. What would then happen when you are now replacing 10% of it with acid? Can I say water content will reduce to 90% of it? So water content will now become 90% of the original water content because now you are replacing it with acid. Just the vice versa of what we did earlier. Earlier we were replacing it with water, so 80% acid remained. Now we are replacing 10% with acid, so 90% of water will remain. So 10% of 76 is very easily, is something that we can very easily calculate. 7.6. So subtract 7.6 from 76. So you get 76 minus 7 is 69, and then 0.6 68.4. So you get 68.4% here. If water is 68.4%, then the remaining will be acid, that will be 31.6%. So we are done with this, and now if we are done with this, finally there is 15% replacement again with water. Now this should be very easy. If 15% is replaced with water, this 31.6 will now become what? 85%. Just like we did 80% here. So now it will essentially become 31.6 into 85 by 100. This becomes your answer. Now how to calculate 85%? You can subtract 10% and then 5%. 31.6 minus 10% of 31.6 will be what? 3.16. This is 10% subtraction. This is 100%, remember. So I am subtracting 10%. Then I am subtracting 5% as well. So what will be 5% of 31.6? You can half 3.16, so it will be 1.58. So roughly, because options are fairly away, you can say 3 and 1 4, and then you have 4.67 something. So 4.6 if you subtract, so 31.6 minus 4.6, somewhere around 27 or slightly lesser than 27. So we have one option as 27, the other options are fairly far away, so we can confidently mark our answer as 27. Correct answer? So answer is 27. I hope this question is clear. So a quick revision of what did we learn. If there is a mixture of acid and water and you are replacing certain percentage with water, let's say 10%, then what will happen? 10% is replaced with water, so the corresponding acid percentage will become 90% of itself. Complement of 100. If you are replacing something with acid, then 100's complement will be the percentage remaining for the other parameter. should be pretty straightforward. Let's look at one more question. CAT 25 slot 1. Take 30 seconds, try and see if you can solve this question quickly using any concept that you have studied so far. Stocks A, B and C are priced at rupees 120, 90 and 150 per share respectively. Alright. A trader holds a portfolio consisting of 10 shares of stock A. So let me write down the price. So price for ABC is given to us. This is 120, this is 90, this is 150. What else is given? Trader holds a portfolio consisting, so number of stocks for A are 10. And in total for B and C combined it is 20. If the total value of portfolio is 3300, now this should be pretty straightforward. The total value of the portfolio is 3300. What is the value from holding stocks A? So it is 1200. 120 is the price, 10 stocks, 1200. So can I subtract 1200 from 3300 to get the total amount available with B and C? That will be 2100. And this 2100 is a combination of total 20 stocks. So can I get an average price for B and C? The average price for B and C will be 2100 divided by 20. That should be how much? That should be 105. Now look at the concepts of average mixed alligation. I am pretty sure that you studied or heard about a concept called alligation, which is nothing but another form of weighted average. So you have B and C priced at 90 and 150. Their average is priced at 105. And if you take the difference, just give me a second. I guess there is again some echo issue coming. Yes, hopefully there will be no more echo. So let's move back to our discussion. So if you take the difference, this becomes 45, this becomes 15. So what does this ratio give us? This is a ratio of 3:1. What is this ratio? This is the ratio of number of stocks. If this is the ratio of number of stocks, 3:1 total becomes 4. And what are the total number of shares that they had? Total number of shares that they had was 20. So multiplication factor is 5. You multiply 5 here. So effectively it becomes 15 as your answer. So correct answer by all of you. So they are asking shares of stock B and C. Shares of stock B will be 15. Correct answer. So 5 will be shares of stock C. Right? Alright, let's look at one more question then. CAT 24 slot 1, and probably the last question for this particular session. Apologies for the disturbances in terms of the issues with echo, but can't really help with some technical issues. Let us know in the feedback, in comments, what did you like, what did you not like as well in terms of the content, not the technical issues. And if you want more of such sessions in the future, if yes, what is it that you would like to have in terms of content, which particular areas in mathematics, TI, LR, even VRC that you want to be covered, so that those specific sub areas or concepts become absolutely clear in your head and you're able to solve questions with a lot of confidence and ease and take less time than what is usually required. So glass is filled with milk, 2/3 of its content is poured out and replaced with water. If this process of pouring out 2/3 the content and replacing with water is repeated 3 more times, then the final ratio of milk to water in the glass is. So how to approach this? The glass is filled with milk, 2/3 is poured out. So let's say if initially the quantity was 1 unit, 2/3 is poured out and replaced with water. So then 1/3 will remain. So we can directly do 1/3 here. So 1/3 is the quantity of milk that will remain. Initially we had assumed the milk to be 1. And now 1/3 remains after one such process. Now this process of pouring out 2/3 and replacing it with water is repeated 3 more times. So this 1/3 is now going to happen 3 more times. 1/3, 1/3, 1/3. So effectively this will become what? 1 by 81 times. So milk left now is 1 upon 81. So if initially milk was 1, now it is 1 upon 81. So the remaining part would be water. So water would be 1 minus 1 by 81. That would effectively become 80 by 81. So now what is it that they are asking? They are asking final ratio of milk to water in glass. So milk finally is 1 upon 81. Water finally is 80 upon 81. When you cancel this, the ratio comes out to be 1:80. So obviously there would be options in the exam. This was not a T-type question. So you can mark the answer as 1:80 when you look at this particular question. So did not get the last solution for shares one. Maybe I'll go back and quickly explain it again. But broadly, the session was intended with this purpose that you understand or pick up a subtopic under a broad heading, let's say average mixtures alligations, pick up question types that have frequently appeared in CAT and other exams, and then become really good at it. So once you have absorbed how to approach, what to do, then you can apply it in similar questions of other types. So you can maybe watch the video again to look at the solution. I just applied alligation in the previous question, so if you quickly go back, yeah. So 90 and 150 were the prices for B and C, and the average price was 105. So 90 and 150, the average is 105. We can apply alligation, take the differences. The ratio comes out to be 3:1, which means if the number of shares of B were 3, number of shares of C would be 1. Total number of shares in ratio would be 4. But because they are saying that 20 shares were there for B and C put together, the multiplication factor is 5. We multiply it with 3 and we get 15 as the number of shares for B. So broadly this is it as far as this session is concerned. Hope to see you in the coming sessions. Do share it in the comments, even if you are watching it later on, or if you have watched it live, please do make it a point to share it in the comments. What is it that you'll be expecting in terms of further sessions that we might want to conduct on this particular platform that can seem really useful for you. So that's all from my side. Thank you for attending, thank you for participating, and a big thank you for being patient despite all these technical difficulties of having echo in the voice. So I take a leave. Thank you everyone. Have a good day.